morning. My name is Prachi. I am B.Sc Chemistry N.R.S student and my topic for presentation is electrochemistry. So, what is electrochemistry? It is the study of chemical reactions which take place at the interface of an electrode, usually a solid metal or semiconductor, and an ionic conductor, the electrolyte. Electrochemistry deals with the interaction between electrical energy and chemical energy. Oxidation reduction. The term redox stands for reduction plus oxidation. It refers to electrochemical processes involving electron transfer to or form a molecule or ion changing its states. The atom or molecules which loses electrons is known as the reducing agent. The substance which accepts the electron is called the oxidizing agent. Standard electrode potential. To allow prediction of the cell potential, tabulations of standard electrode potentials are available. Tabulations are reference to the standard hydrogen electrode. The standard hydrogen electrode undergoes the reaction. 2H positive plus 2 electron gives H2. Standard electrode potentials are usually tabulated as reduction potentials. The reactions are reversible and the role of particular electrode in a cell depends on relative oxidation or reduction potential of both electrodes. The cell potential is then calculated as the sum of reduction potential for cathode and the oxidation potential for anode. For example, the standard electrode potential for copper electrode is cell diagram. Electrical resistivity. It is an intrinsic property that quantities how strongly a given material opposes the flow of electrical current. Many resistors and conductors have uniform cross-section with a uniform flow of electric current and made of one material. The electrical resistivity defined. Rho is equals to Ra by L. Electrical conductivity. The reciprocal of electrical resistivity measures a material's ability to conduct an electric current. मतलब कि वो कितना करंट कंडक्ट कर पाती है उसी को इलेक्ट्रिकल कंडक्टिविटी कहते हैं. It is commonly represented by sigma. Conductivity is defined as rho is equals to 1 by sigma is equals to 1 by rho. Conductivity SI units of Siemens per meter. Molar conductivity. Molar conductivity is defined as the conductivity of an electrolyte solution divided by the molar concentration of the electrolyte and so measures the efficiency with which a given electrolyte conducts electricity in solution. From definition, the molar conductivity is delta M is equals to kappa by C. Two cases should be distinguished: strong electrolyte and weak electrolyte. For strong electrolytes, salt, strong acid, strong bases, the molar conductivity depends only weakly on concentration. For weak electrolytes, the molar conductivity strongly depends on concentration. The more dilute a solution, the greater its molar conductivity due to increased ionic dissociation. For weak electrolytes, obeys Ostwald's dilution law. Clausius law of independent migration of ions. High accuracy in dilute solutions. Molar conductivity is composed of individual contribution of ions. Limiting conductivity of anions and cations are additive. The conductivity of a solution of a salt is equal to the sum of conductivity contribution from the cation and anion. Battery. Many types of battery have been commercialized and represent an important practical application of electrochemistry. Early wet cells powered the first telegraph and telephone systems and were the source of current for electroplating. The zinc manganese dioxide dry cell was the first portable, non-spillable battery type that made flashlights and other portable devices practical. The mercury battery using zinc and mercuric oxide provided higher levels of power and capacity than the original dry cell for early electronic devices. Lead acid battery was secondary battery. The electrochemical reaction that produced current was reversible, allowing electrical energy and chemical energy to be interchanged as needed. Lead acid cells continue to be widely used in automobiles. The lithium battery, which does not use water in the electrolyte, provides improved performance over other types. Rechargeable lithium-ion battery is an essential part of many mobile devices. Corrosion. Corrosion is the term applied to steel rust caused by an electrochemical process. Corrosion of iron in the form of reddish rust, black tarnish on silver, red or green may be appear on copper and its alloys such as brass. Prevention of corrosion. Coating. Metals can be coated with paint or other less conductive metals. This prevents the metal surface from being exposed to electrolytes. Scratches opposing the metal substrate will result in corrosion. Sacrificial anodes. The method commonly used to protect a structural metal is to attach a metal which is more anodic than the metal to be protected. This forces the structured metal to be Catholic, thus spared corrosion is called sacrificial. Zinc bars are attached to various locations on steel ship hulls to render the ship hull Catholic. Other metal used magnesium. Electrolysis. The spontaneous redox reductions of a conventional battery produce electricity through the different chemical potential of the cathode and anode in the electrolyte. Electrolysis requires an external source of electrical energy to include a chemical reaction, and this process takes place in a compartment called an electrolytic cell. Quantitative electrolysis and Faraday's law. Quantitative aspects of electrolysis were originally developed by Michael Faraday. Faraday is also credited to have coined the terms electrolyte, electrolysis among many others while studying analysis of electrochemical reactions. Faraday advocate of the law of conservation of energy. It was the first law. First law, the mass of products yielded on the electrodes was proportional to the value of current supplied to the cell, the length of time the current existed, and the molar mass of the substance analyzed. The amount of substance deposited on each electrode of an electrolytic cell is directly proportional to the quantity of electricity passed through the cell. And this is the formula. Second law, the amounts of bodies which are equivalent to each other in the ordinary chemical action have equal quantities of electricity naturally associated with them. The quantities of different elements deposited by a given amount of electricity are in the ratio of the chemical equivalent weights. Applied aspects of electrochemistry. Industrial electrolytic processes, electrochemical reactors, batteries, fuel cells, some electrochemical devices, electrochemical methods of analysis. Branch of electrochemistry. Photoelectrochemistry. It is a field of study within physical chemistry. The interest in this domain is high in the context of development of renewable energy conversion and storage technology. The effects of luminous radiations on the properties of electrodes and on electrochemical reactions are the subject of photochemistry. Semiconductors electrochemistry. Semiconductor material has a band gap and generates a pair of electron and hole per absorbed photon if the energy of the photon is higher than the band gap of the semiconductor. This property of semiconductor material has been successfully used to convert solar energy into electrical energy by photovoltaic devices. Semiconductor electrolyte interface. When a semiconductor comes into contact with the liquid to maintain electrostatic equilibrium, there will be a large transfer between the semiconductor and liquid phase if formal redox potential of redox spaces lies inside semiconductor band gap. At thermodynamic equilibrium, the Fermi level of semiconductor and the formal redox potential of redox passes and between interface semiconductor. This introduced N-type semiconductor and P-type semiconductor. This semiconductor used as photovoltaic device similar to solid-state PN junction devices. Both N and P-type semiconductor can used as photovoltaic devices to convert solar energy into electrical energy and are called photoelectrical cells. Biochemistry. It is branch of electrochemistry and biophysical chemistry concerned with topics like cell electron-proton transport, cell membrane potentials, and electrode reactions of radioenzymes. Biochemistry is a science at the many junctions of sciences. Nanoelectrochemistry. Nanoelectrochemistry is a branch of electrochemistry that investigates the electrical and electrochemical properties of materials at the nanometer size regime. Nanoelectrochemistry plays significant role in the fabrication of various sensors and devices for detecting molecules at very low concentration. The term electrochemical nanostructuring can be used to mean different things. This term is employed to refer to generate at will of nanostructure on electrode surface involving a given positioning with a certain precision. The term nanostructure is used to describe the generation of nanometric pattern with more or less narrow size distribution and periodic or random ordering on the surface, but without control on the spatial location of the nanostructure. What are the applications of electrochemistry? There are various extremely important electrochemical processes in both nature and industry. The coating of objects with metals or metal oxides through electrodeposition and the detection of alcohol in drunken drivers through the redox reaction of ethanol. Diabetes blood sugar meters measures the amount of glucose in the blood through its redox potential. The generation of chemical energy through photosynthesis inherently an electrochemical process. Production of metal like aluminium and titanium from their ores. For photoelectrochemistry, artificial photosynthesis, regenerative cell or dye-sensitized cell, photoelectrochemical splitting of water. And for biochemistry, some of different experimental techniques that can be used to study bioelectrochemical problems. Ampermetric of biosensors, biofuel cells, and bioelectrosynthesis. Thank you.